Richard, hello, good morning. Thanks for coming. It's my honor to interview you, to ask you the questions about object-oriented programming. Richard Pawson is the author of Naked Objects Concept and many other things we're going to talk about today. Hi, Richard.
Здравствуйте.
Thanks. Yeah. Thank you very much. My first question to start that discussion, who do you think you are? A teacher, a computer scientist, or a software engineer, a programmer?
Well, it certainly varies year to year and possibly by day of the week. All of those. I tend to say computer scientist now, but that's because my focus is now toward education, and it makes that clearer. But I've been many things. I've been a journalist. I've been a toy designer. Much of my career is in software engineering, but I think careers are only defined retrospectively. They're not defined in advance.
That's right. But I see a lot of code contribution on your GitHub account. It seems that you are a programmer.
I write code every day. Yes. Although I wasn't the primary implementer of naked objects, I did a lot of coding in the naked objects framework and obviously using naked objects. And more recently, I've done more and more coding. Unlike most people, I think, who've had a varied career, where they tend to start out very technical and end up very managerial. For me, it's almost been in reverse, where, I had some good basic technical groundings from my education, and then went more into the kind of managerial and marketing side, and then gradually got more and more technical as I went on.
Some people would say that that's not a successful career, right? Because most people don't like coding, so they try to jump out of that and go to management.
Oh, I see it the other way around. I am more fulfilled in what I'm doing now than I have at any time in my career, and that's I've been programming for 50 years, and I've been working for 48. So I've done a lot of things, but I love getting up in the morning, and I'm often coding sitting in bed before I have to get on with other things.
That's amazing, because I do the same, so that's why it really resonates with me. And I don't feel it's like a degrade of the career to go from management to coding. It's actually going up in my view as well. Yeah,
absolutely. And I think particularly more these days. I mean, in the early days of software development, you had this, not just the waterfall methodology, but you had very much a kind of waterfall management approach where you had project managers and systems analysts, and they thought they really owned the process and dumped it all on the coders, whose job was just, they thought, to translate what they'd written into the arcane stuff of computing. Well, modern software development isn't like that, and yet we still sort of teach it a little bit like that way, to me, most of my coding is sort of exploratory in nature. I'm figuring out what it is I want to do by coding it and saying, no, that's not quite what I wanted, So I code to understand what it is I'm thinking, not just to implement what I've thought out.
Do you think there are many other people, famous people, software people, who are also do the same, or it's quite unique situation?
No, I don't think it's unique. I think it's becoming more that case. I think that software development is regarded as much more of a craft now. It perhaps was in the very early days of computing as well. And I'm very, very interested in the early history of computing. In the sort of 40s and 50s. But then we went through this period where it was very much a controlled thing, and they tried to separate the thinking from the translation. Today, I guess I'm probably the software developers I interact with aren't necessarily representative of the whole spectrum, but I find that most software developers I talk to, I think the same way that I do, like that.
And even the famous developers, like people who are the creators of programming languages, who the authors of the famous books, they also, you think, are still programming, writing code?
Oh yes, I mean, I've had the good fortune to meet several of my heroes in software and computer science in general. I mean, Alan Kay in particular. Someone I interact with quite a lot now is Simon Peyton-Jones, who's the lead on Haskell, and who's been very helpful to me. And yeah, I find that there was a special journal celebrating the death of Niklas Wirth, who died at the beginning of last year. And he, right up to the end, was coding, and what astonished me was how quickly he could create a new language. For me, it's a long, slow process, but yeah.
And let's talk about the naked objects. I think everybody is waiting for that now, because I'm also interested in object-oriented programming, but naked objects showed up as a concept way before I started to say anything about object-oriented programming. What is it, naked objects? What's the core idea behind this?
Well, perhaps it would be useful if I said a little bit about how it came about, and then the definition will become clearer. I first started doing a little bit with OOP in the late 80s, but I wasn't coding professionally at that time. It was just more kind of hobbyist. And most of my work was in mainstream enterprise systems development. And there were two streams of thought. I was in a sort of research field. And one was I was very interested in empowering user interfaces. And the phrase I used to use was treating the user like a problem solver, not like a process follower. And that meant what they call giving the user a first person experience, the sense that they are driving, not that they are responding to a process oriented system that was just asking them to feed in the details. So more like using, let's say, a drawing program or a spreadsheet, but actually using it for mainstream business purposes. So that was one angle. And that's what got me into object-oriented user interfaces. And there was a lot of very good work on object-oriented user interfaces, mostly in the kind of personal tools, the Mac and before that, the Xerox Star and all that kind of thing. And then IBM did some extraordinary work in the 1990s called Common User Access that was about creating object-oriented user interfaces for mainstream business activities rather than the personal creative activities. So that was one stream of my research. The other interest of mine was in object orientation as object modeling, what would later become known as domain-driven design, but that term didn't appear until about 2001, 2002, I think, when Eric Evans wrote his book. And those to me were two separate things. And I wasn't hugely knowledgeable about object orientation. I was competent in it. I'd done real object modeling. And I assumed that those two things were deeply connected. I assumed that when you saw a common user access object-oriented user interface, that was a direct connection to an underlying object-oriented model, the domain object model. And it turned out, to my astonishment, that wasn't the case, that IBM actually said in its CUA guidelines, I didn't see this for a long time, that an object-oriented interface does not imply an object model underneath. It's just an implementation of the layer. And I thought, you've got to be kidding me. I mean, to me, these ideas are just so obviously deeply connected. Now, I didn't even know the word reflection at that point in the technical sense of the word. What I would now say is, if I was now expressing that feeling, that I would assume that the user interface was a reflection, literally, of the domain object model. And the more I searched for this, I thought this can't be a new idea. This must be what everybody's doing. And then I discovered it just wasn't true. And I started to theorize how might it be true. I didn't at that time have the ability to make it so. You
Mhm.
know, I just said, why can't we say, well, if you have a domain model that consists of customer, product, order, let's say, why don't those simply appear as customer, product, and order? And why don't their methods simply appear as menu actions, what we would today call context menu actions, right click?
Mhm.
Um, surely that's how it should be done. Now, certainly that was being done in, for example, some drawing programs, but it wasn't even done in any mainstream system. And then in the sort of mid 1990s, we started to see the emergence of object relational mappers.
Mhm.
Like Hibernate, I think, was one of the early ones. And then later, because most of my work was in .NET, it would be Entity Framework, but that was rather later. And so people were starting to say you shouldn't have a domain object model and then a separately maintained representation of this in SQL. One should be derived from the other. And if you think of the early ORMs and Entity Framework in particular, early on it really didn't work that well. You had to have intermediate layers of mapping files, and then eventually people sort of saw the light and said, oh no, this should be completely the same, completely automatic. Now, what I was trying to do or thinking how to do was how to do that upwards, how to say, let's take that same Pojo or Poco, depending whether you were Java or .NET in those days, domain model and create the user interface from it entirely automatically. And I teamed up with a friend who was a better software, more technical software developer than I was. I was more on the modeling side. And he said, well, we could do this. We could, and I thought he didn't really get it. And then he turned up a couple of weeks later with a first prototype of this thing. And I thought, my goodness, he has got it. He has understood what I'm trying to say. And that was the beginning of what became the Naked Objects framework.
Hmm. Why did you call it naked objects? Just curious.
Oh, it wasn't originally called naked objects. It was called expressive objects because my work on my theoretical work on user interface design was called expressive systems, and so the framework was initially called expressive objects, which is a bit of a mouthful. And I think in the UK, well, you may know him. He's known internationally. There's a very famous TV chef called Jamie Oliver who he wrote a book called The Naked Chef.
Mhm.
And then I started to see the word naked appear. You saw naked hi-fi, naked motorcycles, which had no fairings on them, and I thought this is a trend. It's basically saying no adornment. Jamie Oliver was saying just the ingredients, let all the ingredients speak for themselves in the final dish. And it just suddenly came to me, and everybody I said it to in the next week said, yes, that's it. And so that became the name of the idea, and eventually my PhD thesis. So my PhD thesis is called Naked Objects. And very occasionally that causes problems. There was when my book first appeared, um, it appeared on not on Amazon, but on one of the other big booksellers at the time. And the description of the book was all about deviant sexual practices.
Jeez.
And obviously got it mixed up with someone else's book, but generally it doesn't cause problems to me. But it raises a few eyebrows, and that leads to conversations, and that's useful in its own way.
But this is not how people design their systems these days. They have something in the database, then they have something in the application layer, and it's completely different things. The objects are disconnected entirely.
And I have to say, naked objects has not been the success that when we actually got it properly implemented, I thought this is going to change the world of software development.
Mm-hmm.
And it hasn't. We had we're still very much live, one enormous success with it in the Irish government, which is used at incredible scale and incredible complexity of domain object model. And then quite a lot of people tried it. And yet the strange thing is, I mean, I haven't actively tried to promote it for a good many years now. And then periodically, about 3 or 4 times a year, I get an email from someone I've never met, usually a long way away from where I am, New Zealand, Argentina, South Africa, whatever. And then most recently, Moscow, your email. And the emails always begin, when I first read this idea, I thought, yes. But it isn't the norm, and we might explore why that is, because the other thing I missed out about my original research was when I started to get interested in object-oriented domain modeling. The rationale for object-oriented domain modeling, to me, primarily is agility. It's the ability to articulate a change in business requirements and translate that easily, not instantly, but easily into a change in the system. And what I found was that benefit, that claimed benefit of OOP, simply wasn't being realized at scale. And I think the primary reason for that is that if your domain layer has a separate database layer and a separate handwritten mapping layer between those two, and then above it, you've got a process layer and a presentation layer, or a task layer and a presentation layer, and so on, that it's all very well being able to say, well, this business change translates to just this one tweak in the domain model. But now you've got all the stuff above and below it that's out of sync and has to be matched and tested and all that. And so most quote object-oriented systems and let me stress, I'm talking in the realm of sort of enterprise business systems. I'm not talking about personal tools and apps and that sort of thing. That most of them are very, very unagile. The effort required to make a change is disproportionate to the scale of the change as originally expressed. And yes, it is a tremendous disappointment to me that the idea was not taken up far more widely or even copied. I mean, we were open source from very early on. We weren't open source right at the beginning, but we open sourced it, and other people did copy it, but they didn't have any more success with it getting it established than we did.
I think people don't understand objects these days as abstractions of some real things in the real world. They just treat objects as data structures, which just hold the data, which is temporary, need to be held by somebody, and that's it. That's why the names of the objects are not even, they don't even resemble anything from the real world. We have so many services, so many factories, so many singletons, so many proxies, all these things, but they're not really real abstractions of anything.
Yeah. And a bet noir of mine was that so many of the names end in er, in that they're verbs. They're not objects should be nouns from the domain. I'm very proud of the fact that in the Irish government, the last time I was directly involved in it, there were 5,000 domain classes, and you may think, well, that's absurd, but literally 4,500 of those classes were recognizable nouns from the business domain. The complexity was because of the enormous complexity of the domain of government regulations in social services. There were not all these bizarre, there were very, very few classes that couldn't be recognized by a user. There are very few classes that weren't ever seen directly by a user. And one of the effects that we had from that, and I'll come back to this point about why I think it wasn't picked up, but what we observed as huge success was that the users talked in object terms, because that's what they were interacting with. And they would be saying, can I have another method or action, they might call it, on this object that does this? Because they understood what the objects were. They meant something to them. And occasionally we would introduce, because I was the lead modeler there, and I thought very abstractly. And so I would introduce an abstraction that would be new to them. And very quickly that would take on. They would say, oh, hadn't thought about it that way before, but that does make sense. We haven't used that word before, but that does make sense in our terms. And so it was a two-way flow. But you said, and I agree with you, that there aren't that many people doing real domain object modeling, let's call it that, to get it away from naked objects. But I think there's a second problem, and it's taken me years to sort of articulate this. I think that I and the few people I know who really got naked objects are slightly different from other developers. I like to think, an expert object modeler, and I express my object modeling not in diagrams. I don't draw UML diagrams, but I express them in code as plain old objects with the properties and methods that I want. So I enjoy writing code in Java or C# or TypeScript or whatever, but I am not a very good technical programmer. If you say to me, make this system talk to that system, no, I have people who are very, very good at that, but I'm just not good at that kind of thing. And I don't think there are that many programmers who enjoy the analysis of business problems and their expression in code, in working code, as an object modeler. I think you've got people who think they're analysts and even think they're modelers, but because they don't understand code, they don't design good object models. And then you've got many other programmers who are far better than I am technically, but who I think subtly regard a framework like naked objects as disempowering them. Because what do you mean I can't tweak the UI just to do that? What do you mean I can't touch the UI? What do you mean I can't hand map, to the database and so on? And I think so in other words, the problem with naked objects was, who is it going to appeal to? It doesn't appeal to the most technical developers because they see it as too restrictive. It doesn't, at the other extreme, you get people who don't really know how to program, who think that naked objects is the answer. They think it's a kind of end user development tool. It isn't. You've got to be a competent programmer in C# or Java or whatever in order to be able to use something like naked objects. But you've got to be really interested in talking to business users. So part of the root problem is that in big consulting, if it's different in small teams, but in big consulting, which is what does the big enterprise systems that I'm talking about, you still have this analyst developer divide, which is astonishing to me, because I think what tools like naked objects do is break that down completely and say that what we need are what was once called the analyst programmer. And there aren't all that many developers, I think, who really identify with that. When someone who is like that sees naked objects, they go, yes, this is how it should have been all along.
As a teacher, you definitely know that young software developers are not taught to think about objects. They're taught about something else. And if you look at any competition which is organized for young developers, for programmers, they're all about algorithms. They give them tasks to solve some algorithmic problems, and they do that, and they compete in this domain. But they don't compete in object design, in modeling, like you just said. So what do you think about that as a teacher? Is it possible to teach them that, or we have no?
But let me just qualify the as a teacher. 8 years ago, at the age of 57, I very suddenly became a school teacher. I'd never no teaching experience in schools prior to that. I've run training courses and the like, but that's for professional developers. And I suddenly became a school teacher, and I taught A-level computer science in a very good British school, and A-level is age 16 to 19. And I was shocked by what it happened so quickly. I was prompted to do it by Alan Kay, amongst others. But it happened very quickly. And I found myself, having never been a teacher, thrust in this environment. It was quite scary, quite and teaching things that just shocked me. So I identify with what you said to a great extent. It's not strictly true, at least in Britain, that they're not taught OOP. They're taught some OOP, even at age 16 to 18 in the A-level syllabuses. But it's a fairly small part of the curriculum. And while there are teachers who, like me, at that time had come from industry and therefore did understand this, an awful lot of teachers who come up from teaching very crude procedural programming, or they've taught ICT, which is just how to use computing, and then they've been forced to learn a bit of programming. And they've sort of learned and can parrot out what encapsulation means, what inheritance means, but they don't really get it, and so their pupils don't get it, and so you see very basic common mistakes, such as that in all the school textbooks I've read on OOP, inheritance is the big thing, the be all and end all. Now, most professional software developers who understand OOP regard inheritance or implementation inheritance as a fairly minor thing and actually quite a dangerous thing a lot of the time. Type inheritance is a different issue altogether. But so you get that sort of mistake come out. And then I've been astonished when I've talked to teachers, and I'm quite well known in the teaching community for computer science in the UK now. I know a lot of teachers, and I often get requests for help on OOP to understand it, and it quite surprises them. Sorry, first of all, when I say inheritance isn't that important, polymorphism is far more important than inheritance. And one of the A-level syllabuses even has patterns like favor delegation over inheritance. I've never met a teacher yet who understood what that meant, because even the textbooks explain it very, very badly. But another thing that surprises me is that most of those teachers can teach relational database and basic SQL perfectly well. They understand that perfectly well. I'm astonished at the number of people who have never seen even a conceptual connection between a relational model on a database and an object model. They've never seen that an association between objects, which is something you're required to learn, is just like a foreign key in a relational model. And in fact, if you use object relational mapping, that is what it is. But but they've not even seen that concept. And so yes, as a teacher, strengthening the understanding of OOP was important to me. So I wrote a small free textbook which I published on my website, metalup.org, understanding OOP, and I wrote a draft of this, and it was all taught through actually writing a simple drawing program where you actually understood what the objects were and how the methods related to what you could do with the drawing things. And I had this bright idea before I published it that I would ask the great Alan Kay, who I've known for years and years and years, who I haven't spoken to for quite a while though, if he would write a foreword to this book. I thought this would be fantastic. You know, he of course, for those listening who perhaps don't know his name, he was the chief scientist of the research learning group at Xerox PARC in the early 70s. He was the co-author of Smalltalk with Adele Goldberg. He's a Turing Medal winner. He's a Kyoto Prize holder, which is like Nobel Prize in Japan. One of the greatest minds of our generation, I think. And I thought he wouldn't even reply to the email, let alone. And he said, "Oh no, sure, I'd be happy to do that." And I thought, wow. So I sent him the draft. Now I've known Alan Kay for a very long time, and he's a lovely man, but he's also very blunt. And he sent me back this critique of my book, and I wrote back to him and I said, "Alan, was there anything you liked in the book?" And he said, "You need to do more on this, you need to do more on that." So I went back and I rewrote it and I sent it to him again. And he came back and he said, "Perfect." And I said, "So will you write the forward?" And he said, "Yes." And then I thought, there's one thing that he says yes, it's another thing altogether to get it from him. And so I waited and I waited and I sent him a prompt email and another one. And then eventually he came back about a month later. He said, "I'm so sorry I haven't written this forward," he said. And I'll use this exact phrase. He said, "But I couldn't get it to land." He said, "I've written 12 different forewords to your book and I'm not happy with anyone, but I'm going to now write a 13th and I'm going to send it to you." And he wrote me the most lovely foreword to the book. But that's so Alan Kay. I mean, that whenever you hear him speak, if he speaks to an audience of, you know, about OOP or about anything really, half the audience goes away saying that was incredible, and half of them go away saying, "What the hell was that about?"
Really?
He's off in the stratosphere. Brain operates at a plane above, or several planes above mine. But I've learned so much from the man. I'll tell you, your watchers might enjoy this one. When I was I knew him from the early 1990s when I was really just beginning to learn OOP, and I would meet him every 3 months or so, and he would set me tasks. And he would say, for example, I remember one of them was, "Do you remember HyperCard? Do you remember, you know, an early Apple, you know, map sort of personal tool with an object-oriented interface?" He said, "Write a version of HyperCard." And I thought, yeah, that doesn't sound too difficult, right? This software's moved on. He said, "But you can only use 3 classes." Ah, okay. So you're really going to have to think of some good abstractions. And so I would do that. He would say, "Good, now do it in 2 classes." And then, you know, eventually he'd come back and say, "Now do it in 1 class." And because he once said to me, I once asked him, if you had done Smalltalk all over again, no, not Smalltalk. If you had done the first GUI, you know, the first GUI that was copied by the Mac all over again, how would you do it differently? And he said, "Well, I would only use 1 class." And I said, and first of all, he quoted me. I don't know if you remember the film City Slickers. Do you ever see the film City Slickers? There's a line in there where the old cowboy, played by Jack Palance, says to the young one, played by Billy Crystal, "You know, son, I've learned there's only one important thing in life." And Billy Crystal says, and what's that?" And Jack Palance says, "That's what you got to find out." And Alan used to do that. Alan used to do that to me. But eventually he said, "Well, the class is smart rectangle that contains other smart rectangles." There's your GUI.
Right. He's well known for the development, for the creation of Smalltalk, but Smalltalk is not used in any production system these days. We use C++, we use Java, we use .NET, C#. Do you think that was a meaningful contribution to the computer science, this Smalltalk, or maybe C++ was the actual contribution? And this is actually the object-oriented programming. Because many people complain about the definition. They say, you guys are talking about not the object-oriented programming. The Smalltalk is not object-oriented programming. C++ is.
Well, I will say this, that okay, I'm getting on in years, but amongst people I know who I think get object orientation, many of them, their first exposure was to Smalltalk. They don't use Smalltalk now, but I think it created a better awareness than C++ did. C++, of course, is much, vastly more widely used. And then, heaven help us, what do we teach in British schools? Python, which is, one of the worst implementations of OOP that I can understand. So I think Smalltalk was important from that sense. But I hope Alan Kay isn't going to listen to this because I might lose his friendship. The only point I disagree with Alan on is that he thinks the correct answer to almost everything is dynamic typing, and I don't like dynamic typing. And so to me, although I first explored OOP and sort of got to get it was through Smalltalk, I didn't start writing professional systems that used OOP until Java came along. And I don't think I even was so consciously aware at the time, but the huge difference was the static typing and even the very first IDEs for Java. I'm trying to remember what it was called now, but the very first visual something. Oh no. You got the help. You typed dot and you could see what the methods were, and you knew what the thing that
Auto-completion.
Sorry?
Auto-completion.
But you can't get auto-completion if you don't have static typing. So, yes, I mean, Smalltalk was a dead end. I once heard David Ungar speak. He was the author of Self, which, of course, actually ultimately inspired JavaScript. But Self was not a popular language, and he was asked why wasn't Self more popular, and I identify with this because I get asked why wasn't Naked Objects more popular, and he's very dry sense of humor, David Ungar, and he said we made a mistake with Self. He said we used square brackets, and I didn't realize that the future was curly brackets. It was a very dry comment at how shallow people's evaluation of languages is. But I thought it was great.
But I think, and people say that, including David Ungar in his papers at that time of the development of Self, is that the performance is the key problem in object-oriented programming because of dynamic dispatch. It's just slow, and static typing and static binding is what makes languages faster, and this is what programmers prefer. They don't care much about the design, they care about the performance, and this is what made Smalltalk not popular, and other languages, which are Java and C++, way more popular.
But it was also garbage collection, and that was solved, with Java and later languages. Garbage collection was a nightmare in early Smalltalk. But my response to that is, I don't write operating systems. I'm not interested in whether operating systems are object oriented or not. In fact, I would probably make a quite strong argument that they shouldn't be. And I would agree with that. But I'm not interested in writing operating systems. I'm interested in writing business systems and user tools. And performance is just not an issue there. Well, sorry, that's not correct. The performance is entirely dictated by the database. It's nothing to do with the dispatch or we've profiled the systems we built, and whenever there's a complaint about response time, it's never anything to do with the object model or the naked objects framework or the language. It's entirely to do with the database. So I think let me broaden that discussion. One of the things that took me years and years and years to learn is that when people talk about scalability, they're talking about different things. And one group of people are talking about volume and response time and latency. And another group of people, and I'm in that other group of people, when we talk about scalability, we mean scalability for complexity, not scalability for performance and volume. And business systems in particular have far more of a problem with scalability for complexity than they do with scalability performance. If you're writing an operating system or a telephone exchange, I mean, this is why, UML and that whole, what was it? What was the methodology called that the Swedish guys did?
RUP.
Yes, RUP. Thank you. What was that designed for? It was designed for telephone exchanges. Telephone exchanges are an engineering problem, right? Most business systems, this is not true of ultra high performance, social networking and so on. That is an engineering problem, right? But the kind of business systems I developed, which was still big, but they were, they were not engineering problems fundamentally, or the engineering problems were very separable from the development of the system. We didn't have to consider performance. And that's, I think, part of the problem with this conversation is that the people who are saying that, oh, OOP doesn't perform, people who are interested in engineering problems, whereas the real value of OOP is in managing complexity, requirements complexity, domain complexity.
But then the people who cared more about performance, they go to the domain of the OOP and teach OOP programmers how to design objects. And this is where the confusion comes from, because there are different concepts, different way of thinking. But we have to listen to them because they sort of control the operating system domain. They control the performance, and they say, we know that static binding is better. So that's it. Listen to us. And students, they start listening because these people have the reason to say that, I think. Because I totally agree with what you said, that we care about complexity way more at the level of business applications. By complexity, you mean maintainability, right, of the code?
Yeah, maintainability, extendability, yeah, exactly.
And how does your programming language, ELAN, what kind of problems it solve and what it's for, what it's about?
Okay, so ELAN is a very relatively recent development. I've been working on it for the last 2 years. ELAN stands for Educational Language. There was, in fact, a programming language called ELAN in Germany in the 1970s called ELAN. It has no connection to that, but that doesn't exist anymore. It's a programming language designed for education, designed to learn programming. Now, that in itself is interesting because one of the immediate, by the way, it's not fully released yet. It's going to be released next month. We're on 1.0.0 pre-1 right now. We released a beta last July, but it's going to be released 1.0.0 in May. But as I'm talking to teachers say, but what are you going to see? If we were to adopt this, if we were to teach ELAN, never mind it's all the advantages that you've articulated, what do you say to a parent who says, why are you teaching me, my child, a language that isn't used in industry? ELAN is never going to be used in industry. We're going to make sure of that. We're not. Every other language that was introduced as an educational language, BASIC, Python, Pascal, were all designed as educational languages, all ended up evolving where the requirements were dominated by professional developers, not by learners. Now, my answer to that question, why are you proposing to teach a language that isn't used in industry, is threefold. First of all, many languages are used in industry. If you teach children, let's say C#, what is the chance that, the organization they want to go and programming in is using C#? That's going to massively limit, if that's their view, that you've got to learn the language that you're going to program in, is going to limit their sellability. Secondly, You can't, at least not in the UK, walk out of high school into a programming job unless it's sort of web maintenance, or something like that. You've got to go to university and study computer science or a computing related degree if you want a decent programming job. And there you're going to learn lots of different languages anyway, hopefully, if it's a decent university. And thirdly, you're asking the wrong question. You should be asking the question, what we should be teaching children to program in is a language that better prepares them to go into different languages and to learn, and more, even more important than that, is a language that teaches them to program well, not teaches them to program. Any fool can program, right? Not any fool can program well. And so one of the things we've done in ELAN is said, well, even at the level of procedural programming, first of all, we're going to simply outlaw lots of things that you can do in most languages. There are no global variables. So you don't have to learn, because what happens now in schools is first you write global variables. Then when you get to sixth form, age 16, you're told not to use global variables. Okay, well, why let them do that in the first place? So that was the first one. You can't break out of a loop in ELAN, because that's against structured programming. That predates structured programming. You shouldn't have the word break in any language. You'd be amazed at the number of experienced programmers who react to that. Say, we've even said you can't return from more than one place in a procedure or a function. You've got to return at the end. That's the only place. You can only have one return statement, and that's got to be at the end. Because it makes you structure things better. But it's convenient to be able to shortcut that and return from 15 places in a function. Yeah, but it ruins the maintainability. Oh no, we can fix that with what's it called? Not eventually. What's the keyword you can stick at the end in some languages that says finally? You're going to finally, and that fixes it. Well, that fixes it because you've messed it up, right? So all these things we said, you simply can't do those. The most controversial one is, and this is the one I'm proudest of. I'll come to OOP in just a second. Most controversial one is this is the first multi-paradigm language that I know of. Some of your viewers may point out different to me, but I know quite a few languages where we make a proper distinction between a procedure and a function. In ELAN, from the get-go, from the very first time you write a function, you cannot create side effects in it. You can't. Oh, but how am I going to debug, sir? I need to put a print statement in here. No, you can't put a print statement in there. Well, how am I going to debug? Use the debugger. It's bad practice to stick print statements in things to debug them, because that can create all kinds of side effects. You can't create a side effect in an ELAN function. In that sense, it's like a functional programming language, but it is not a pure functional programming language. It is designed to allow you to do pure functional programming. But more important than learning pure functional programming, there's only one exam board in the UK that has a little bit of functional programming, a tiny bit of functional programming in the curriculum. It's going to mean that when you do transition to a functional programming language, it's going to feel very natural, because you're not going to have to, but how do I do that? Because I'm used to doing this in a function and now I can't. Well, you never learned that way in ELAN. So that's the functional programming side is quite important. Now on OOP, it's got good support for OOP, but we've deliberately made it simpler than a good OOP language like Java or C#. Notice I don't say Python. I don't consider Python to be a good OOP language. We don't have the complexity deliberately. I mean, I've built, I told you, systems, 5,000 domain classes, 5,000 business domain classes. You need a lot of sophistication to do a model that big. You don't need that sophistication to write something with 20 classes in it, which is about as much as you could ever expect anyone to be doing when they're learning, OOP. And so, for example, we've again tried to say, well, let's make it enforce good practices. a pattern that many OOP developers cite is every class should be abstract or final.
Right.
In other words, you should only inherit from abstract classes or interfaces. You shouldn't inherit from other concrete classes. And so we've got that you have abstract classes, we actually have interfaces. So we've gone for the C# Java model where you can inherit from one abstract class and as many interfaces as you want. You can't inherit from another concrete class. We've also said that in an abstract interface only contains abstract members effectively. In an abstract class, you can't define public concrete methods. We've said you can define private concrete methods, and I should point out that private in our terms means protected in
Java.
C#. It means it's visible to the subclasses. So every abstract method you've got to implement yourself in your concrete class, but you can delegate back up to the shared implementation. And people say, oh, that's a restriction, you know. But first of all, it stops this emphasis on implementation inheritance, which dominates the teaching of OOP at school level. And it teaches you, delegation over inheritance and the convenience of being able to delegate up to a common or partial common implementation in the superclasses there. But so we've got no overriding. That means you don't need overriding. So it's a simpler model of OOP, but it is a good model of OOP. If anyone criticizes ELAN's model of OOP, I shall have to play all my ace cards about my experience in this field. It wasn't designed that way because we didn't know better. It was designed that way because we want people to understand the important things about OOP, not all the trivia. Yes, if they go on and build huge object models, they're going to have to learn more techniques, but you're going to have to learn more patterns anyway if you're going to program at that level. You don't expect to learn it all at the beginning. What it gives you is a great foundation in OOP.
You may get into conflict with other teachers who teach other way of OOP, and they may say you spoil our children by giving them something which goes against what we teach them, right?
I'm under no illusions that it's going to be enormously difficult to get ELAN established. It's hard to do anything innovative in the education sector anyway. And with Python being the dominant language, the only language that many teachers know, it's going to be hard. What I haven't covered, because this isn't primarily a session about ELAN, is that there are other huge advantages. We have this radical, the language and its IDE are a single thing, like Smalltalk was actually, and you use it just online. There's no install. You can install it on a school server, but it's just online. You access it at elan-lang.org. And it's got this radical editor. There's a big debate going on in British schools at the moment, or there was, about whether block-based languages, which are taught at primary school, that's, Scratch and Snap and things like that, should be taught at secondary school. And the Department for Education in the government here wanted to make that possible to use block-based languages at school level, at secondary school level. And there was quite a reaction against that from teachers, which I'm sort of quite pleased about in a way. I sort of think you do need to grow up into text-based languages. But of course, the huge advantage of block-based languages is that it gets rid of syntax errors. You concentrate on the code. And the distinction is actually it's non-binary. Scratch is a text-based language. It's a text-based language with a lot of constraints around it. And we've done that thing. If you look at ELAN, it looks like a text-based language. It looks very familiar. In fact, if you look at a program written in ELAN, you might wrongly come to the conclusion that it was what we call a noddy language, just a play language. It's not. It's a quite advanced language, actually, particularly its support for functional programming, for example. It's quite an advanced language, but it looks very simple. It reads a little bit like BASIC, but it isn't like BASIC. But it's got this editor that means you can't create a syntax error. If you're at global level and you type the letter F, you'll get the template for a for loop, much like you do in many IDEs today, but with the difference that in most IDEs, those code snippets are only there while you create the code. Once you've created the code, it's all freely editable. You can edit the keyword, you can delete the brackets and so on and get syntax errors. In ELAN, that construct remains a hard construct. You can delete it, you can transform it into another kind of thing, but you can't edit the word for or remove the brackets around the parameters. They are in there and hard, even though it just looks like code. So that's a big thing. Most professional developers will hate that. But it's not designed for them. It's designed for kids struggling in school. Professor Michael Coling at King's College, who's very well respected in this field, he wrote Blue Jay and Greenfoot, and his team have written Stripe and Stride, which are all educational languages. And he says there is nothing useful, there's no useful learning that comes out of fixing syntax errors. There's enormous useful learning that comes out of fixing logic errors in what you've written. But when if you sat me down and said, write me a C# program in or TypeScript or anything in Notepad, it definitely wouldn't compile what I wrote. I'm very dependent upon the IDE. There's no useful, even at my age and experience, I make, 10 syntax errors in a single line of code if I'm not getting help to correct it, just like I, depend upon spell checker to some extent. There's no useful learning from syntax errors. Get them focused on the logic of the thing, not on the matching brackets and getting the casing right and the keywords correct and so on. So it's quite radical in that sense as a language.
From what you're saying, I'm driving to the conclusion that we must teach in universities and schools for a number of years only the theoretical languages, which are created the right way, not to work fast, not to complete their tasks fast, but to be well designed. But now it's not happening. Now the first year they start teaching them C++. All the kids which I teach also as a teacher in a university, they all come to me at the second or third year. Already they know how to write C++ code. How do you know? I ask them. They say they teach us at the first year.
Yeah, no, that's absolutely true. And yet, if you critique their code, they look at you and well, it works, doesn't it? I mean, why do I need to change that? I mean, that just introduces more errors. They don't come out with the idea that yes, you got it to work. That's the first step. Now refactor it. Now make it better. Now make it more readable. Now make it more generalizable. That's another nice thing. You've got to go and look at this yourself, Yegor. Unit tests are a first-class feature of ELAN. You type the word T, you get a framework of a test. The tests just run. You don't ever have to run them. Every time the code compiles, the tests run, and you get an indication next to every assert. You can have as many asserts as you like. It doesn't, if the first one fails, it still does the others, and you just get a red or green with a pass or fail all the time right next to you, right there. You can put the tests don't have to be in a separate class or a separate project. They could be right underneath the function in the source code. And so I argue we should be teaching unit testing from the very first function that you write. You can only test functions in ELAN. That's deliberate. It's dangerous to test procedures because they've got side effects in they create side effects. So it's another good incentive to do everything you can in functions. Same goes in object orientation. We have function method and procedure method. very distinct, following the same rules. If you want to modify the object, it has to be in a procedure. If you want to query the object or derive something from the object, that's a function. And it's like, if you just learnt that from the beginning of programming, what Bertrand Meyer called command query separation, that every method should either be a command, it changes the state of the system, or it should be a query, which returns new information, and never the twain should meet. Because I loved his way of describing this. He said, asking a question should not change the answer.
That's good.
It's like, these are the things you need to be learning. I'm often astonished in teaching, what do I know now that I didn't know at school and yet could have been taught? And I've sometimes listed these things out. Example, right? I actually did 4 weeks of Russian when I was at school, but it was 50 years ago, so I don't remember that any of it really, apart from Strasbourg and Australia. And I know. Sorry, digression. The Russian word for railway station is Vauxhall. Is that correct?
Correct. Yes.
You know why?
No.
It's named after Vauxhall, which is a district of London.
Oh.
Every Russian railway station is named after Vauxhall.
Nice.
The only other thing I remember. No, but what I was saying was, right, I had to do French at school. How do you, masculine and feminine? We don't really have that in English. It's like, well, what's masculine and feminine? There's no rules. You just have to learn them all. Well, it turns out there are not 100% rules, but there are heuristics. If I'd have been taught those from the beginning,
right,
I'd have understood masculine and feminine properly. Yeah. Second order differential equations. It wasn't until I went to university that I understood a fundamental point about them, that if I'd been taught from the beginning, I would have struggled much less with them. That sort of thing. Well, I think the same is true in programming. It's, what are the things that you really wished you'd been taught from the very beginning? Separation of concerns is a huge one for me, right? Mm-hmm. Refactoring, naming, unit testing, naming. I'm obsessed with naming, unit testing. These are things you could teach from day one in programming, and ELAN actually encourages that.
Bertrand Meyer, who you mentioned already, he was teaching at the same university where I'm teaching now, and he was teaching programming on his own language, Eiffel. And I remember he said, he said a few times that not all the students get happy about that, because they don't know the answer for the question, why do we need this language? What's the point of spending time on Eiffel? Because we're never going to write anything in this language in the future. So that's the question, not only about changing the program in the university, but giving some incentive to students to motivate them to learn something which they know they're not going to be able to use in the future. That's probably the question.
So what I would say if I was in front of the students myself was, if you learn ELAN, you're going to find it a lot easier to transition either into a purpose-designed object-oriented language or into a functional language. And secondly, you're going to surprise people who you encounter in industry with what you know about good programming. Mm-hmm. Which is not the case today. You're going to go in there and you're going to be saying to, your peers, but why are you creating a side effect in this function? What? Yeah. Well, shouldn't have side effects in function. What are you talking about? What are you talking about? It's like, these are the things we need to get right from the beginning today.
And these functions you call naked functions, right? Okay.
No, naked functions was a later development of naked objects. It is a alternative version of the naked objects framework, where you can't tell the difference at the UI. It is in fact the same client. It's just that the programming model is different, where you can make all your objects immutable and all of your methods pure functions, even though it's primarily designed, really only designed for database-centric systems. Mm-hmm. I've talked to functional programmers who have no interest or knowledge of relational database systems. they deal in data mining and scientific data analysis and so forth. Well, actually, the same principles of having every method completely testable in a unit test, because it does nothing other than create something from the inputs it was given, the parameters it was given. So it was a way of doing naked objects, still with objects and methods, but where every method was 100% pure and side effect free, and every object was immutable. It was even less successful than naked objects, but I was very proud of it because I thought I'd at least proven that you can build very pure object-oriented systems using pure functional programming techniques. Um, so that's just on the scrap heap of my unrecognized ideas.
Okay. Okay, I know you're running out of time, so let me ask not the question but suggestion. Maybe we can ask our watchers to join your project, maybe ELAN. Let's give them some call for action. What's next? If they like what you said, if they share the same thoughts.
In the first instance, go to elan-lang, L-A-N-G, .org. That's where the pre-release is. There's some documentation linked from linked from it. Although I would say, see if you can figure it out without any documentation at all. You probably need to read the documentation on how to use the editor. The first time you use the editor, it'll be a bit surprising because you do very little typing. But there are demo programs on it. You can start by reading those. And as I say, your first reaction when you read them might well be, oh, this looks like a pretty noddy sort of basic language. It isn't, trust me. There's a really good thing to look at. There are 3 demos of Snake. One is, they're all written in ELAN. They're all under 100 lines of code. One is a pure procedural implementation. One is a pure OOP implementation, and one is a pure functional implementation of the game Snake. The user interface, you playing the game is identical, and it's 100 lines. And actually look at what I've done in there. Look at why they are different and how they are different. And if you're an experienced programmer, I learned more from doing that. It wasn't an easy exercise because I had to define, if you're using a multi-paradigm language, what does it mean to make it pure procedural? What does it mean to make it pure OOP? What does it mean to make it pure functional? So I wrote down my own kind of rules and constraints and followed those. And then I looked at it, and the most startling difference is testability. The functional implementation I wrote as many tests as I could. I wrote as great a test coverage as I could, but ELAN tests only test pure methods, side effect free methods. And so the functional one had to work with immutable objects and with side effect free methods only. And it's an interesting exercise. Go and have a look at that. If you're interested in getting involved, then get in touch with me. I'm not hard to find through GitHub, or you managed to find me. So I won't announce my email.
Do you need some contribution in the code or maybe bug reports if people join your project?
Yes, bug reports definitely. Contributions, we would love to have contributions, but that means you contribute something we have agreed.
Of course.
I do not take
just whatever,
where people go, oh, I think you should do this. I mean, I had one guy, we show the line numbers on the right. He said, I don't like that. I've rewritten it so the line numbers on the left. Sorry. Okay. No. We designed the thing, right? If you want to contribute and are willing to, discuss with us what it's going to do and what would be the most useful thing to do, we would love it. But we don't want people saying, oh, this is a new language, I'm going to take it in this direction. That's not how my kind of open source works. So.
All right, then we'll give all the links below the video. They will be able to find you, to submit their code if they like, the bug reports, everything. Let's make this language interesting for the students.
And look, naked objects is not now a world-changing phenomenon, but it's well worth looking at because you can get a better understanding of how to do good OOP. It's still being maintained. We're still maintaining it, but most of the focus is on ELAN now.
Mm-hmm. Thanks for the interview. It was really interesting for me personally, as a developer, as a programmer.
Thank you. Well, I'll have to finish with До свидания.
До свидания.